But wait a minute. These humidity readings are usually measured at a weather station miles away, such as at an airport, and can be a whole lot different from the reading at your dealership location. So, for a more accurate check, you'll need a sling psychrometer. The sling type is simply two glass bulb thermometers with one of them wrapped with a braided wick. This wet bulb gives us information on the amount of moisture in the air, while the dry bulb tells us the ambient temperature of the air surrounding us. Let's see how to use it. Wet the wick in clean water so that it is thoroughly saturated. Then, whirl it around for as long as it takes to count silently to 20. Then, without going into great detail, simply remember that the greater the difference in the readings between the wet and dry bulbs, as we see here, or, as shown here, the lower the relative humidity. In other words, the drier the air, the faster the moisture can evaporate from the wet bulb and the lower its temperature becomes. We call it relative humidity because it compares ambient temperature with the amount of water vapor or moisture present in the air. Now to continue. The less difference there is between the wet bulb and the dry bulb readings, as shown here, or here, the higher the relative humidity. That is, the wetter the air. For additional details, study the reference book. Now, applying this information to the AC system, let's keep this in mind. The evaporator must not only lower the temperature of the air passing through and over the fins and coils, but when the humidity is high, it must also remove the heat in the moisture before it can lower the temperature of the incoming air. As this moisture comes into contact with the evaporator fins, it condenses into drops of water. In doing so, a great deal of the heat energy contained in every particle of vapor is transferred into the evaporator fins and tubing. As a result, this added heat load placed on the evaporator reduces its cooling ability. In a sense, you can almost say that as the humidity becomes higher, the evaporator literally shrinks in size. Now, let's run through some typical examples of relative humidity and how it affects the temperature of discharge cooling air. Let's assume a wet bulb shows a 70-degree reading at an ambient temperature of 88. This figures to relative humidity of 40%. Therefore, if the AC system is operating properly, discharge air should be 58 degrees, which corresponds to the discharge temperature listed in the cooling performance chart for the wet bulb reading of 70 degrees. Now, let's once again assume the climate has changed on the following day and relative humidity reaches 96%. This is equivalent to a wet bulb reading of 87 and an ambient temperature of 88 degrees. When this climate condition is present, discharge air temperature from the outlets will rise to 77 degrees, which is normal under the circumstances. So you see, at the same ambient temperature, but two different humidity levels, there's a 19-degree difference in discharge cooling air. In both examples, the AC system is okay. It's just that the high relative humidity placed a severe heat load on the evaporator. Now, let's see how this knowledge about relative humidity can help in the event a customer complains about the amount of cooling air his AC system is delivering. For one thing, there are some that have overly high expectations. They feel they should get instant cool down after the car has been standing in the hot sun or on a muggy, sultry day. However, it is often necessary to make an overall cooling performance test to assure him that his AC system is operating at full rated capacity. To do this, all you need are a few pieces of equipment to find out if the AC system is delivering all of the cooling it's designed for at the prevailing ambient temperature and relative humidity. Now, connect the test equipment so that you can read the gauges when you close the hood. Check each of the couplings to make sure the seals are not damaged or missing. Momentarily loosen, then retighten each hose coupling so that refrigerant can flow through the lines and bleed out air. With the engine off, the gauges should show equalized refrigerant pressures. If okay, start the engine and roll the windows down so that the blower can purge the interior of hot air. With the temperature control lever in the cool position, push the selector button for AC mode, not max AC. Blower switch at high speed. Insert an accurate thermometer into the right center outlet. By the way, make a regular practice of checking thermometer accuracy by placing it in a jar filled with crushed ice and water. 32 degrees should register on the dial. Now to continue. Set all other discharge air outlets so they also face directly to the rear of the car. Adjust engine speed so that you get a steady RPM of 1,300 for 8-cylinder cars or 1,600 RPM on 6s. Higher or lower engine speeds will affect test results. Now, let's first make sure we have the right amount of refrigerant charge before we make our cooling performance check. Compressor discharge pressure should show between 225 and 250 pounds per square inch. If not, block airflow through the condenser to increase pressure and bring it within the specified range. A continuous stream of bubbles or foam in the sight glass indicates the refrigerant charge level is too low. Check for refrigerant leakage. When you correct the leak, charge the system following normal service procedures. Now we proceed to our cooling test. Close the hood without pinching gauge hoses. Now let's put our sling psychrometer to work. After the sock end is saturated in clean room temperature water, take a reading near the cowl area. Without touching the thermometer glass, quickly note the readings. Repeat the check to be certain your reading is accurate and shows no change. Now, for reference later on, record both the wet and dry bulb temperature readings. Then, after a wait of 5 minutes or so, it's time to look at the discharge pressure gauge reading. Remember, the AC system must stabilize before you can prove or disprove its cooling ability. Pressure should settle somewhere between 190 and 210 pounds per square inch. These specs are important for this particular test and must be maintained for accurate results. If below 190, increase discharge pressure by reducing the flow of air through the condenser fins. As a word of caution, never leave the covered condenser unattended because discharge pressure can go extremely high. If discharge pressure should go higher than 210 without the condenser being covered, bring it down into the specified range by using a high-volume fan to blow extra air through the condenser. Once the discharge pressure gauge stabilizes at a point within the correct range, it's time to check the temperature of the cooling air. Carefully note the reading, and from the information you now have, refer to the appropriate cooling performance chart for the wet bulb reading recorded earlier. Here it is, 80 degrees. At this wet bulb reading, discharge air temperature should be close to 66 degrees or somewhat lower. This AC system is operating at its full capacity. But remember, this cooling performance check must be run at ambient air temperatures between 75 and 100 degrees Fahrenheit. Otherwise, discharge air temperature registered on the thermometer will be lower or higher than called for. Yet, if ambient air is within limits, but discharge cooling air is approximately 2 or more degrees higher than called for by an accurate wet bulb reading, you may want to refer to the diagnostic charts for isolating the problem. One of the least likely to malfunction is the compressor. And by the way, a number of changes have been made in the RV2 compressors that you should know about since they affect service. Your reference book covers this information in detail.